Conductance, electrolytic cell, electrochemical cell, Nernst equation and batteries. Conductance. It is the reciprocal of the electrical resistance or resistance which opposes the flow of current. It is directly proportional to length, inversely proportional to area of cross section of conductor, or proportional to L by A. R is equal to rho L by A, where rho is equal to specific resistance or resistivity. Resistivity, the resistance offered by 1 cubic centimeter of solution. Specific conductance. It is the reciprocal of resistivity rho. The conductance of 1 cubic centimeter of the solution. K is equal to 1 by R into L by A. Specific conductance is equal to conductance into cell constant. In CGS, ohm inverse, centimeter inverse. In MKS, mho meter inverse or Siemens meter inverse. SI unit of conductance is equal to Siemens S. Molar conductance. It is the conducting power of ions produced by 1 molar solution if electrodes are separated by 1 centimeter distance. Relation between molar conductance and conductivity. Molar conductance is equal to K into volume in ml is equal to K into 1000 by molarity. In CGS, ohm inverse, centimeter square, mole inverse. In MKS, ohm inverse, meter square, mole inverse. Equivalent conductance. It is the conducting power of ions produced by 1 normal solution if electrodes are separated by 1 centimeter distance. Relation between equivalent conductance and conductivity. Equivalent conductance is equal to K into volume in ml is equal to K into 1000 by normality. In CGS, ohm inverse, centimeter square, equivalent inverse. In MKS, ohm inverse, meter square, equivalent inverse. Conductance on dilution. Specific conductance decreases on dilution. On dilution, the number of ions per unit volume decreases. Molar conductance increases on dilution. Molar conductance is directly proportional to volume. On dilution, molar conductance is more for weak electrolyte than strong electrolyte. Why? Because already KCl ionized. Equivalent conductance increases on dilution. Equivalent conductance is directly proportional to volume. Conductance at infinite dilution. There is no further ionization on dilution, that is zero concentration. Kohlrausch's law at infinite dilution. Molar conductivity is the sum of ionic conductivities of cation and anion. Molar conductance for barium chloride is equal to 1 molar Ba plus 2 molar Cl minus. Equivalent conductivity is the sum of equivalent conductivities of cation and anion. Equivalent conductance of barium chloride is equal to equivalent conductance of barium and equivalent conductance of chloride. Note, molar conductance is equal to N into equivalent conductance at 0 concentration. Electrolytic cell. Electrical energy converts into chemical energy. One equivalent weight deposited by 1 Faraday. 1 Faraday is equal to 96,500 coulombs is equal to 6.023 into 10 power 23 electrons is equal to 1 mole of electrons. One equivalent weight is equal to atomic weight by valency. Example, Al plus 3. Equivalent weight is equal to 27 by 3 is equal to 9 grams. If charge is 3, it requires 3 Faradays to deposit 27 grams of aluminium. Electrochemical series for metals. Discharge potential increases from potassium to platinum. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, Hg, Ag, platinum. Reduction potential is negative, that is anode. Reduction potential is positive, that is cathode. For non-metals, F minus, SO4 2 minus, NO3 minus, OH minus, Cl minus, Br minus, I minus. Discharge potential is more for iodine. Means iodine is liberated first at anode. Note, 4OH minus gives 2H2O plus O2 plus 4 electrons. Electrolytic cell, Faraday's first law. W is equal to etc. Where E is equal to electrochemical equivalent, E by 96,500 coulombs. T, time in seconds, C, current in amperes, W, weight. Faraday's second law, W1 by W2 is equal to E1 by E2. Note, equivalent weight of oxygen 8 grams, silver 108 grams. Electrochemical cell. Chemical energy converts into electrical energy. Zn plus 2, Cu plus 2, Cu. ABC, anode, bridge, cathode. E cell is equal to E naught, reduction cathode minus E naught, reduction anode. For a working cell, E naught cell should be positive. E naught cell, it is an intensive property. 2x plus 2 electrons gives x2. X plus 1 electron gives x. E naught cell is same for 1 and 2. It does not depend upon electrons. E naught cell is equal to 0 for standard hydrogen electrode, She for concentration cells. E naught cell standard cell potential is measured at 298 Kelvin, 1 bar and at 1 molar. Delta G naught. It is an extensive property. Cu plus 2 electrons gives Cu. Cu plus 1 electron gives Cu. Delta G naught is same for 1 and 2. It depends upon electrons. Cu gives Cu plus 2, or in one step Cu gives Cu plus 2. For that calculation purpose, delta G naught is equal to minus N F E naught cell, where N is equal to number of electrons, F Faradays. Nernst equation for an electrode. M Plus n plus n electrons gives m, reduction potential. That is E electrode plus is equal to E naught electrode minus 0.059 by n log m by m plus n. M is equal to 1 for pure solids. For hydrogen electrode, H plus n electrons gives half H2, reduction potential. E H plus to H is equal to E naught H plus to H minus 0.059 by n log H2 whole power 1 by 2 by H plus. Here H2 1 atmosphere. For a cell, E cell is equal to E naught cell minus 0.059 by n log Kc. Kc is equal to Ksp. For a concentration cell, it is not in CBSC but better. That is, chemical reactions are same. EMF arises due to the mass transfer. For a given reaction, at anode of H2 gives H plus 1 electron. At cathode, H plus 1 electron gives half H2. Overall reaction of H2 plus H plus gives H plus half H2. If C1 is equal to C2, Kc is equal to P2 by P1. E cell is equal to E naught cell minus 0.059 by n log P2 by P1. Note, E naught cell is equal to 0 for concentration cells. Batteries. Series of electrochemical cells known as battery. Two types of cells are there. They are primary cell, example dry cell. At anode, Zn gives Zn plus 2 electrons. Cathode, MnO2 plus NH4 plus 1 electron gives MnO OH plus NH3. Secondary cell, example lead battery. At anode, Pb plus HSO4 minus gives PbSO4 plus HS plus 2 electrons. At cathode, PbO2 plus HSO4 minus plus 3H plus 2 electrons gives PbSO4 plus H2O.